In the previous video, we looked at two fundamental concepts, class and object. In this video, we're going to re-explore those two concepts, but we're going to add a few more. We're going to add the concepts of method, parameter, and data type. And we're going to do that by exploring various versions of this project that we saw in the BlueJ setup video. In this project, we have several classes shown in the BlueJ window, and we saw that by creating an instance of the picture class, we got a picture of a house, where the house is composed of instances of the different shape classes that are shown in the project. As a starting point, we're going to review the concept of class and object or instance. So here we have a class triangle. From our previous thinking about classes, we can anticipate that we could have a variety of instances of the class triangle. For instance, the triangles might have different side lengths, they might be different colours, they might have different orientations, and so on. Now, we can model the concept of a triangle by writing some Java source code in the form of a Java class. And that's what we're doing in this project, which is a stripped down version of the picture project that we looked at earlier. Given a class, we know that we can create an instance of that class, which we do here. And that object appears on the area known as the object bench at the bottom of the BlueJ window. Right-clicking on the object brings up a menu. The items shown in the menu are known as methods. Methods provide what is known as the behavior of an object. They arise from source code that's written inside the class. We will gradually explore the methods that we see here to see what sort of behavior objects of type triangle have. One of the methods is called makeVisible. If we select that, then a canvas area appears on the screen and the triangle reveals itself. Let's try another method to see what effect it has on the triangle that's shown on the canvas. We select Move Down, and the triangle moves down on the canvas as we might expect. Another method is called Move Right, and as we might expect, the triangle moves right. In effect, when we call a method on an object, we're asking it to perform some task, and the object decides whether it's willing to perform the task, and if so, it carries out the action. We can also ask the triangle to move down if we wish. You might have noticed that one feature of these requests is that we didn't actually tell the triangle how far we wanted it to move in any particular direction. The source code of the triangle class has predefined how far it will move in each of the directions without us having to say so. In some cases that'll be convenient, but in other cases we might want more flexibility, say if we want the triangle to move a particular distance in one particular direction. Let's look at one of the ways in which we can provide information to a method to say exactly what we want to happen. In this case, we want to change the colour of the triangle from green to some other colour. If we're to do that, then we need to supply to the method call the extra information, which is the colour that we wanted to change to. The method to call is changeColor, and we've chosen to ask the triangle to change its colour to red. One thing to notice is that we have to put the word red between double quote marks, otherwise the colour will not be recognised. At this point, it's worth looking at what features a triangle contains that we might wish to change aside from the colour. To view the internal contents of an object, we can select Inspect from the menu. An enlarged version of the object representation pops up, and we can see that it has a number of fields with values within it. These describe its height, its width, its X position, Y position, and colour, and there's also a visibility. Let's change the triangle's colour again to see what effect this has on the representation that we've just brought up. We've changed the colour to blue, and not only does the triangle show as blue on the canvas, but the representation, or inspector as it's properly called, shows the blue value that we typed in. Let's now look at the effect of calling some of the movement methods to see how the movements reflected on the canvas are also shown in the inspector view. The same is also the case if we choose to make the shape invisible or visible again. the isVisible part of the inspector again reflects whether the triangle is visible or not. What we are actually doing each time we call a method on the triangle is to change the internal state of this particular instance. The fact that an object has state is fundamental to object-oriented programming, and the fact that methods sometimes alter the state of an object is also a fundamental concept. A feature of classes is that we can create multiple instances from them, so let's create a second triangle and bring up the inspector. We've previously characterized a class as being rather like a blueprint, and the point about a blueprint is that every time you create a new instance of that blueprint, those instances are identical, and if we compare the inspectors, we can see that the internal structure of the two triangles is identical. However, while the structure of the two triangles is identical, notice that the states of the two triangles are not identical. This is because we've already performed some manipulations on the first triangle. We've asked it to move, we've asked it to change its color, and so on. Whereas the second triangle has the state that the writer of the triangle class decided it should have when it was created. And in fact, all triangles created from this class will always have an identical state at their starting point. Of course, that doesn't prevent us from changing the state via method calls, as we've seen in this example. All triangles that we create have the same methods, so we can make exactly the same kind of state changes on the second triangle as we made on the first. When we were moving the first triangle, we noted that we didn't actually have to tell the triangle how far we wanted it to move. The distance was defined by the source code of the triangle class. Suppose we want now to move the triangle by a particular distance. One of the things we'll have to do is to provide it with that piece of information that says how far we want it to move. We've already seen an example of this when we changed the color of the triangle. We passed in a color such as blue or red. This time we want to pass in a numerical value. We're going to pass it into the slow move horizontal method. What we're doing in providing extra information to the method is called passing a parameter. Here the parameter value we're passing into this method represents the distance in pixels that we want the triangle to move slowly. Here's another example. This time we want the triangle to move vertically, but not animated this time. It's just move vertical. Now here's a further example. We want to change the size of the triangle, but there's a difference because triangles have both a width and a height. So now we have to pass two parameters into the change size method, one for the new width and one for the new height. We always have to provide both values, even if we only want to change one of them. Let's summarize what we've seen so far. Each object has a set of methods, and methods define or implement the behavior of an object. An object is responsible for managing its own state, and that state consists of a set of data values. Method calls often result in a change of state of an object. Methods can take parameters, and parameters are data values. Parameters alter the effect of methods. And we've seen two data types so far: string, which is data that we write within a pair of double quotes, or integer, or int, which is numerical data. Before we move on, it might be useful to look at some of the source code that we've been referring to in the demonstrations so far, just to very quickly illustrate some of the way in which state and methods are defined. I won't expect you to understand a lot of what you see, but it will just give you a flavour of the kind of things we'll be exploring in more detail later on in the course. Opening up the triangle class, we see the state information that was previously represented in the inspectors that we opened for objects. We see the place at which the initial values of the state of an object are defined. And then we have the definitions of various methods that we've called in the illustrations that we've looked at so far. And as I say, we'll be looking in much more detail about how we might write source code like this and what it means. Let's go back now to where we started this discussion of triangles. We looked at the idea of having a triangle class where different instances of that class might have different colours, different sizes, different orientations, and so on. And we can extend this idea to other shapes as well. Why not have a circle class or a square class, where each instance of those individual classes has its own colour, its own size, and so on. And that then leads on to defining a BlueJ project in which we have triangles, circles, squares, and perhaps other shape types as well. And all of the features that we've seen illustrated with the triangle class apply equally to those other classes as well. So we can create a circle, call its methods, and bring up an inspector. And then do exactly the same for any other shapes that we choose to create. All of these shapes have methods, some of which take parameters and some of which don't. But the important principle here is that the way that we will be creating and interacting with objects throughout this course is exactly the same. We've seen pretty much all we need to know about how to create instances and interact with them. And of course, what most of the rest of this course is going to be about is about how we write the Java source code that allows us to get this kind of functionality. So now that we've got our basic shapes, we can think about how we might make use of them in a further project in order, for instance, to draw the picture of the house that we looked at earlier. So the idea is that this picture consists of instances of the various shapes that we've seen. Triangles, circles, squares. But what we need to do is write a new class called picture that makes use of instances of those other classes that we've already looked at. And here's just a brief glimpse into the source code of the picture class that shows how we're using triangle, circle, square in order to build up the composite picture from the individual shape elements. And we'll look further at the details of this as the course progresses. And just for fun, here's another version where we've actually animated the pieces coming together in order to make the house, using things like the slow move vertical and slow move horizontal methods that we've illustrated.